Hello everyone and welcome to day 36 of our low-level design journey. Today is a special day. It's not about learning new theory, but about applying what we have learned so far. We are going to focus on project discussion and peer review. This session is critical because it helps you strengthen your design thinking, practice presenting your ideas clearly, and most importantly, learn how to give and receive feedback just like you would in a real-world engineering team. Let's start by understanding what we aim to achieve today. First, each of you will present and explain your mid-course low-level design projects. This is your opportunity to showcase your understanding and creativity. Second, you will experience something even more valuable, giving and receiving constructive feedback. Learning to accept feedback with an open mind and offering it thoughtfully to others is one of the key skills of a great engineer. Third, we are going to simulate real-world design discussions, the kind that happen in design review meetings in companies like Google, Amazon, or any tech startup. And finally, you will practice defending your design choices, explaining your trade-offs, and communicating your design rationale, an essential skill when you work with other engineers, product managers, and architects. Now let's walk through how today's session will unfold. We will begin with a 20-minute preparation phase where you will get ready for your presentations. Then, for about an hour, students will present their designs, explaining the problem, the design choices, and the challenges they face. After that, we will shift gears into peer review sessions where you will analyze each other's works using a structured review format. Finally, we will wrap up with instructor feedback where I will highlight best practices, common mistakes, and insights from your work. Think of today as a mini conference. You are both the speaker and the audience. Before you step up to present, make sure you have ticked off the presentation checklist. You should have submitted your project at least a day before, so we have a version for evaluation. Your actual presentation should be concise, around 5 to 7 slides is ideal. Make sure your deck covers these key elements. Start with your problem statement and any assumptions you made. Next, give a high-level architect overview to show how you structured the system. Then dive into your class diagrams and interfaces. This is where your low-level design skills really shine. Also, highlight where and how you applied solid principles. This shows depth in your design thinking. And finally, be honest about the challenges you faced, the trade-offs you made, and the decisions that weren't easy. Good design is never perfect. It's about making smart compromises. When reviewing your peer's design, it's important to be both structured and thoughtful. The peer review sheet is your guide for this. Start by asking, does the design actually meet the requirements? This is the foundation of everything. Think about scalability and maintainability. Will this design still work if the system grows 10 times bigger? Look at how well the solid principles are applied. Is the design flexible, extensible, and easy to understand? Review the UML diagrams. Are they clear, logical, and easy to follow, or do they create confusion? And finally, think of specific suggestions. What could be improved or simplified? The goal is not to tear down someone's work, but to help them and yourself build better designs. Throughout the presentations and reviews, there are a few important concepts I want you to focus on. First, remember, it's not just the final design that matters, but how you reached the design. The thought process is key. Next, talk about trade-offs. Every design decision has costs and benefits. Explain why you choose one path over another. Communicate your design clearly and simply. The best engineers can explain complex systems in a way anyone can understand. And always remember, critique the design, not the designer. Feedback should feel like a conversation, not a personal attack. Peer review is a skill, and like all skills, it can be done well or properly. Here are some best practices. Be specific. Instead of saying this is bad, explain what isn't working and why. Balance your feedback. Point out what's working well, not just the negatives. Ask open ended questions like, have you considered another approach instead of giving orders? And maintain a tone of curiosity and respect. Treat the session as a chance for mutual growth. Remember, today you are practicing for the real world where peer reviews are daily part of a developer's life. During the session, I will play the role of moderator and mentor. My job is to keep discussions focused, professional, and respectful. I will step in to highlight particularly strong examples of design, and I will also point out patterns or issues that multiple students might need to improve. The goal isn't to criticize, it's to help you all level up together. If discussions go off track or get too critical, I will gently steer them back, just like a lead engineer would during a real world review. By the end of today, each of you will complete two deliverables. First, you will write a one-page reflection summarizing your key learnings both from giving and receiving feedback. What did you notice about good design? What did others point out that you hadn't seen before? What will you do differently next time? Second, you will fill out peer review sheets for two or three of your classmates. Remember, these documents are important. They help you build a habit of critical thinking and thoughtful analysis. If you do this well, here's what you will walk away with. You will have sharper communication skills. You will be able to explain your designs clearly and defend them intelligently. You will start recognizing common mistakes early in poor cohesion, over complicated interfaces, or scalability problems. Most importantly, you will build a mindset that is focused on continuous improvement, which is the foundation of a great designer's career. Today isn't just about this one project, it's about building habits that will stay with you for the rest of your engineering journey. Thank you for your attention.